Now let's go to this question. Okay, now in this part, normally, okay, you guys know, normally everyone, most of the students, they have an unusual fear for chemical calculation questions. But if you understand like step by step, like how to do that part, then easily you can do this question. Now you can see here, an iron OX contains FeO and Fe2O3 and inert substances. Right. So FeO means what do you have in this? Like what are the main cations which is involved in oxidation reduction? FeO mean you know it is Fe2 plus. So when you go for Fe2O3, what is it? It is Fe3 plus. Okay. Now they have done the following experimental procedure was used to determine the mass percentage of FeO and Fe2O3 in X. So what they have done first of all, they have done for 0.48 gram of X was dissolved in 10 centimeter cube of concentrated acid. And first of all, they are dissolving this. So with this dissolving, like what are they expecting in this part? They are mainly expecting to titrate, again, to make this medium into acidic. Nothing else is happening because of this, right? And because of this part, like nothing special happened. Like only Fe2 plus and Fe3 plus, both are there. Like nothing new will happen in this. So they have taken only 10 centimeter cube of this concentrated acid. It mark those things. Okay. Now they have taken for 10 centimeter cube. Now you have FeO. Okay, you have FeO and you have Fe2O3. You have both. You have FeO and Fe2O3. Okay. Point with a inert substance. Okay. And some inert substance also there. Yes. So altogether it is 0.48 grams. Altogether 0.48 grams. Now, what they have done, this solution was filtered to remove insoluble matter and thereafter diluted to 50 centimeter cube using distilled water. Okay, now this is in 10 centimeter cube. And they have filtered this. Now they have taken this into a 50 centimeter cube. They have diluted this up to 50 centimeter cube. Okay, 50 centimeter. They have diluted up to 50 centimeter cube. Then this entire diluted solution was titrated with 0.02 m KMnO4. So this was titrated with 0.02 m KMnO4. Right, this was titrated with this. Okay, 0.02 m KMnO4. Right. Uta, can you tell me, like, if you put KMnO4, normally wherever we are using KMnO4, what is happening in KMnO4? KMnO4 will go for reduction. So who can act with KMnO4? There should be a person who can go for oxidation. When someone reacting with KMnO4, can you tell me who can go for oxidation in this? You can reply the chat box. Right. Now KMnO4 is here. KMnO4 going for reduction mean who can go for oxidation? Yeah, tell me someone. Like now, what are the cations present in this? From FeO, you got Fe2 plus. Okay, you got Fe2 plus. First, we'll try to understand the logics. In Fe2O3, you got Fe3 plus. Just now tell me, Now, when you put KMnO4, in KMnO4 can it can go to MnO4 minus. At the same time, then who will react with this KMnO4? This Fe2 plus or Fe3 plus? Who can react? Tagala reply. Who can react with this Fe KMnO4? Yeah, the correct answer is who can react? When you put here only Fe3 plus can react with KMnO4. So understand in this part who is undergoing who is reacting with KMnO4, that is Fe3 plus. First of all, you should be able to decide that part. Okay, then that is fine. Now to the next part. The titration reading at the end point was 20 centimeter cube. It means the amount of KMnO4 required for this titration. The 0.02 m KMnO4, you need 20 centimeter cube. You need 20 centimeter cube for this. You need 20 centimeter cube. Okay. So this is the required amount of KMnO4. Then the titration reading at the endpoint 20 centimeter cube, the pH of the entire solution obtained after the titration was raised to 12. Here they have given. At this stage, the metal ions in solution were precipitated as their hydroxides. Okay, whatever the metal ions here, right? They were precipitated as hydroxides. So what are the metal ions after the titration? After the titration, what are the metal ions present in this? Yeah, after the titration, what will happen, Putha? This Fe3 plus can go to Fe2 plus, right? Okay. After the titration, okay, after the titration, Fe3 plus can go to Fe2 plus. Okay, after this, what can happen? Whatever the Fe3 plus here can go to Fe2 plus. Like whatever the Fe3 plus here can go to Fe2 plus. Right? Okay. Now Fe3 plus can go to Fe2 plus. Then what else here? You can see manganese also here. Now KMnO4 also there. So why Mn2 plus ions also there? No, KMnO4 will go to Mn2 plus. Then you can say after this Mn2 plus also will be there. Now you have two types of ions, right? To precipitate of hydroxides, Fe2 plus and Mn2 plus both are there. So they can get precipitated as hydroxides. They can get precipitated as hydroxides, OH minus. Okay. Then the precipitate was filtered and dried until a constant mass was obtained. Right? The mass of the precipitate obtained was 0.5706 gram. What is this mass? Mass of the precipitate obtained was 0.5706 mean. Okay, this manganese hydroxide and okay, ferrous hydroxide. Okay, you will get MnOH twice and manganese hydroxide and ferrous hydroxide, FeOH twice. Okay, you get these two things. Then these two get precipitate. Okay, this when you take this precipitate's mass and that only 0.5706 grams. Right, that is only 0.5706 grams. Right. The first question is write the balanced chemical equation for titration and precipitation reactions. Okay. So if you write the balanced reaction for this part, okay. If you write the balanced reaction for this part, so we can write like this. The first balanced reaction is okay. This whatever the Fe3 plus reacting with KMnO4, right? Whatever the sorry, Fe3 plus, no, Fe2 plus. whatever the Fe2 plus here, because Fe2 plus will go for Fe3 plus. Therefore, here whatever remaining is Fe2 plus only going for Fe3 plus. It's oxidation. So FeOH tries and manganese hydroxide only the precipitates. Then you can write first reaction will be the reaction between MnO4 minus and Fe2 plus. So you get MnO4 minus. This MnO4 minus will go to Mn2 plus, while Fe2 plus will go to Fe3 plus. This oxidation will happen from this. So you have to balance this. Balance this, you have to add 4 water here. So if you put 4 water, this side you have to put 8H plus and 5 electrons. 5 electron. And here 1 electron. To balance this, you have to multiply this set by 5. And if you write the balanced chemical equation, finally you get here 8H plus MnO4 minus and 5 Fe2 plus. Mn2 plus and 5 Fe3 plus with 4. Okay, so this is a balanced reaction between MnO4 minus and Fe2 plus. Okay. Then if I write another balanced reaction between these, right, Fe3 plus and Mn2 plus, those precipitations also you can write here. You can write Fe2 plus with hydroxyl ions, with Fe3 plus with OH minus ions. It will precipitate as FeOH twice. Precipitate as FeOH twice. Right, then you need 3 OH minus ions. At the same time, Mn2 plus ions will take 2 OH minus ions, and it will go as manganese hydroxide. Go as manganese hydroxide. Right. So these are the reactions. Okay. These are the reactions take place in this. Right. Now, the next part. Now, only this much of reactions happening in this part. And they have asked, now they have asked for, okay, in this question, what they have asked, calculate the mass percentage of FeO and Fe2O3 in X. And they have told, assume that the composition does not change during drying of metal hydroxides. Okay, and there is no effect from dissolved oxygen in solution here. They have asked to assume. Okay, right. Then next. Okay. Okay, now we have to start from a point. Now, first of all, we can see, or from this part, from here, from this set. Okay. See, from this set. Here only Fe2 plus whatever the Fe2 plus in this only the reacting with KMnO4. And who is reacting here? Only Fe2 plus whatever Fe2 plus here only reacting with KMnO4. So if you find the number of moles of KMnO4 here, then what can you do? You can find the Fe2 plus moles. Always the carrying factor is moles. First of all, we can see, I can find the number of moles of MnO4 minus or KMnO4 moles. Okay. So I can find N MnO4 minus, number of moles of MnO4 minus I can find. Right. So, okay, MnO4 moles. Okay. So if I find the KMnO4 moles for the, you can see 0.02 M, 20. No? So how to find the number of moles? Multiply by C into V. Okay, CV. So if you use CV, concentration of this is 0.02. Okay. Concentration of this is 0.02. This is the concentration. Volume will be, you are writing dm minus 3 here. Okay. This is the volume. 0.02 m, 02 mol dm minus 3. And the volume will be, okay, the volume will be of 20 centimeter cube. Okay, the consumed volume of KMnO will be 20 centimeter cube. So 20 centimeter cube, you have to convert to decimeter cube, 20 to 10 to the power minus 3 decimeter cube, you can write it. So if you simplify this, then you'll get, okay, if you multiply this by 20, 0.4 into 10 to the power minus 3 moles scale, you get it. 0.4 into 10 to the power minus 3 moles. This is the KMnO4 moles. If you know the KMnO4 moles, well, from this I can find the Fe2 plus moles. NFE2 plus. NFE2 plus mean, right? That is equal to NFeO moles. Why? Because if you break FeO, right? If you break FeO, how can you break this? You can break this as Fe2 plus and O2 minus. So here you get only one is to one stoichiometry. So number of moles of FeO will be how much, Puta? Right? Same. Okay. You know, this is 5 times of this. So you can see in this reaction. Okay. 1 times of MnO4 minus reacting with 5 times of Fe2 plus. This is 5. 1 is to 5 is the ratio. If 1 is to 5 mean, this will be 5 times of it. Okay. So 0.4 into 10 to the power minus 3 into 5. Into 5. You have to multiply by 5. So if you multiply by 5, then this I have write as moles. 5 moles. So 0.4 into 5 mean how much, Puta? You get 2 into 10 to the power minus 3 moles. So the number of FeO moles 2 into 10 to the power minus 3 moles. So if you know the FeO moles, you can get the molar mass of FeO. Molar mass of FeO will be iron is 56, oxygen is 16. Okay, 56, 66, 72. 72 grams per mole. Then if you know FeO moles, okay, you can find the mass of FeO. Mass of FeO will be how much, Puta? You know, you can find the mass by simple N multiplied by capital N. For simple N, you will get 2 into 10 to the power minus 3. Capital M will be 72 times. So 72 into 2 is 144. 144 divided by 1000 means 0.144 grams kilo. We get the FeO mass. This 0.144 grams mean I can get the mass percentage of FeO as 0.144. Okay, over. I can get what is the mass here? 0.48 gram. 0.48. So if I want to see the percentage, I will multiply this by 100. So if I multiply this by 100, so I get FeO's mass percentage, MOM percentage. So if I simplify this, right? If I simplify this, then the answer will be, okay, 30%. Exactly 30. Exactly. 30. We get 30%. Right, exactly, we get 30%. Right. Now, then this is the answer. This is the mass percentage of a FeO. Puta, did you understand this part up to here? Tagala reply yes, no. Everyone, whoever here, do you understand this part? Right. Others? Everyone, Tagala reply. Taiga is there, right? Are you guys actively participating? Tagala tell. Yeah. Now, the next part. Now we know what is the FeO mass percentage, right? That is the this one. Now, why they have given an inert substance? Because otherwise, what you will do? If you know the FeO mass, you will directly subtract and you will find the Fe2O3 mass. To avoid that, that's why they have given an inert substance. Right. Now, how can we get the Fe3 plus mass? Now, that is only you have to think. You have to think. Okay. Now, you know, you can see this. They have given a mass 0.57 grams scale they have given. Okay, 0.57 grams scale they have given a mass. Okay, they have given the mass as 0.57 grams. Okay. Now, now 0.57 gram kilo they have given a mass. From this, you know, this came from, these precipitates came from whom? One from ferric hydroxide, other one is manganese hydroxide. Okay, you know, ferric hydroxide and the manganese hydroxide. So then, okay. Then under ferric hydroxide, okay. Now, it means now FeOH thrice. What are the two things Fe3 plus came from? One was the original Fe3 plus. Other one is whatever the converted Fe3 plus. You know, one was originally Fe3 plus, like Fe2O3. Other one got converted from Fe2 plus to Fe3 plus. Right? Those are the two things. Now, Puta, what you have to do? Then, and also you know the Mn2 plus moles also. Whatever the Mn2 plus moles available, under that one also you know. that Mn2 plus moles you know. You know the whatever the converted Fe2 plus also you know. Okay. Then if you know those two masses, then you can find the mass of PO-FeOH thrice. So if you know the FeOH thrice mass, okay, you can find the FeOH thrice moles. If you know the FeOH thrice moles, okay, you can find okay the Fe2O3 moles, right? So you have to go in that way, right? So now let's do that part. Okay. Now we can do like this. From this, I can write now already we know what are the Mn2 plus moles also we know. Okay. What are the Mn2 plus moles here? Already we have found here, but we have found with Mn2 plus moles. Whatever the MnO4 minus moles are equal to Mn2 plus moles, 0.4 into 10 to the minus 3 moles. Okay. So I can write Mn2 plus whatever the Mn2 plus will be, number of moles of Mn2 plus will be how much? The number of moles of Mn2 plus will be same 0.4 into 10 to the minus 3 mole. Okay. 0.4 into 10 to the minus 3 mole. This is only Mn2 plus. Therefore, you can find MnOH twice moles also will be same thing. Okay, manganese hydroxide moles also will be same thing. Okay. N MnOH twice. Okay. So number of manganese hydroxide moles also will be this. Okay. So if you know the manganese hydroxide moles, these are Mn2 plus moles. Therefore, you can find the manganese hydroxide moles. Then, if you know the manganese hydroxide moles, I can get the capital M of manganese hydroxide. I mean, the molar mass of manganese hydroxide. So they have given manganese is how much? This is the value of manganese. They have given that 55. Manganese is 55. Then two oxygens mean oxygen and hydrogen. Okay. That oxygen and hydrogen together 17. So 2 times me. What is the molar mass of manganese hydroxide? Yes. Yes, 89 grams per mole. 89 grams. So manganese hydroxide mole I can write to the 89 grams per mole. So if I know that one as 89, if I write that one as 89 grams per mole. Okay, manganese hydroxide moles is 89 grams per mole, mean I can find the mass of manganese hydroxide. Mass of manganese hydroxide will be how much? 0.4 into 10 to the minus 3 mole. 10 to the power minus 3 mole. Okay. 10 to the minus 3 mole. Multiply by 89 grams per mole. If you multiply this, 4 into 9 will be 36. 4 into 8 will be 32 and 35. So you get 35.6 into 10 to the power minus 3 grams. Okay. 35.6 into so these are the manganese hydroxide grams. If you know the manganese hydroxide grams, even you can find the Fe2 plus moles. Again, whatever the Fe2 plus moles also you know from this, you know what is the Fe2 plus moles. Fe2 plus moles is 2 into 10 to the minus 3 mole. So same thing, okay, will be the Fe3 plus moles. Whatever the Fe3 plus produced also 2 into 10 to the minus 3 mole. So whatever the Fe3 plus produced, under that is equal to FeOH thrice moles. So we can write like this, N Fe3 plus number of moles of Fe3 plus, and that is equal to, right, and that is equal to number of moles of FeOH thrice. FeOH thrice. If I write like this, and we know that is 2 into 10 to the minus 3 mole. So if I know this one, so I have to find the molar mass of FeOH thrice. What is the molar mass of FeOH thrice? Can you tell me? MFeOH thrice. Molar mass of FeOH thrice will be how much? 107. 107 grams. Is the FeOH thrice moles. So molar mass. If I know the FeOH thrice molar mass, I can find the mass of FeOH thrice. Mass of FeOH thrice. I can go for the mass of FeOH thrice. If I go for the mass of FeOH thrice, I have to multiply 2 into 10 to the power minus 3 into 107. This was multiplied by 107 grams per mole. So you get here 214 into 10 to the minus 3. 214 into 10 to the minus 3, 0.214. 0.214 grams. This one will be 35.6 into the minus 3, 0.0356 grams. We can write 0.0356 grams. 0.0356 grams. Okay. Now I can see the total grams of this actually this MFE hydroxide from Fe2O3. Yeah, it's very important, from Fe2O3. From FeO, I'm sorry, from FeO. Again, whatever the FeO converted to FeOH, right? So from FeO. That is very important. Because it is from FeO. Now I want these two mass, whatever these two mass, if I subtract from the total mass, I will get the mass of FeOH thrice from Fe2O3. So from this I can find MFeOH thrice mass of ferric hydroxide. Okay, very important. From Fe2O3. From Fe2O3. From Fe2O3. Then how can I get this? 0.214 0.214 plus, actually we have to, the total mass, but we got here. What is the total mass of hydroxide we got here? 0.5706. And from 0.5706. Okay. From 0.5706. 5706 minus 0.0356 plus 0.21. From this, when you subtract, and you will get here the answer as 0.321 gram. This is the, now we found the FeOH rise which came from Fe2O3. Okay, good. Now, so far everything fine. After this, Putha, okay. Now I know what is the mass of Fe2. Now from this, what can I find? Now I can break, if I break FeOH twice, if I break FeOH twice, Putha, if I break FeOH twice, and I can break it as Fe3 plus N OH minus Fe3 plus N 3 OH minus. At the same time, if I break the Fe2O3, I can break it as Fe3 plus and 3O2 minus. This should be 2 Fe2, 3 plus. So it means whatever the Fe3 plus here, whatever the Fe3 plus here, that is the same Fe3 plus. These both are same. Whatever the Fe2 through TO3 moles is, can you see, is half of the Fe3 plus moles. So you can see Fe3 plus moles are equal to the ferric hydroxide moles. So mass of ferric hydroxide, if I find, so using this, I can find the ferric hydroxide moles. So I can find NFeOH plus. Okay, I can go for NFeOH plus. If I go for NFeOH price, I can find the number of moles of FeOH twice. I know the mass of FeOH twice is 0.321. So I want the molar mass of FeOH twice, already we know. What was the FeOH twice molar mass? 107. Then what should I do? Point 321 divided by 107. So exactly you get very easy simplification here. Okay, these grams per mole. So you get 0.003. mole scale unit. You get 0.003 moles. This is the number of moles of FeOH from Fe to Fe3O4. Therefore, you can find NFe3O4 should be half of this. 0.003 divided by 2. So you get 0.0015 moles. Then this is the Fe3O4 moles. So if you know the Fe3O4 moles, now the only thing is you have to find the molar mass of Fe3O4. What is the molar mass of Fe3O4? If you had everything. Yes. Molar mass of Fe3O4 is 168. Fe2O3, I'm sorry. Fe2O3, Fe3O4, Fe2O3. And 60 grams per mole. So you can find the mass of Fe2O3. Zero point 0.0015 moles. Right, by 0.0015 moles multiplied by 160 grams per mole. Then you get the value. Okay. As how much? Finally, to simplify this, 0.24 grams. 0. This is the mass of Fe2O3. So if you know the Fe2O3 mass, we can find the mass percentage of Fe2O3. So Fe2O3 is mass percentage will be Fe2 mass percentage. But this will be 0.24, 0.48. So you have to multiply this by 100. So you get the answers. So if Fe2O3 percentage will be 50 here. Then the inert substrate is 20%. Okay. So we get the answer like this. Okay, so we have to go for a long journey to get these answers. Okay, but everything is connected. You know, from the question itself, we should understand. Okay, like how it connects. Okay, how it connects. Okay. Now, okay. Now, did you understand? Did everyone understand this part? Is it clear? Like whatever the necessary things, if you have, you can mark those things. You can zoom this. Right. I'm gonna mark these things. Now see this part. This part I will give you the idea. A mixture X contains only aluminium sulfide and ferric sulfide. So you got Al3 plus ion, Fe3 plus ion, and S2 minus ion. The following procedure was carried out to calculate the mass percentage of aluminium sulfide and in 2021 A-level question. Okay. So the following procedure was carried out to calculate the mass percentage of aluminium sulfate and ferric sulfide. In X. So here you have an advantage. Directly only aluminium sulfide and ferric sulfide. Then a mass M of mixture X was heated at high temperature under hydrogen gas. Aluminium sulfide remains unchanged. They have given already about the reaction also. But ferric sulfide was converted to iron metal kilo they have given. So they have already given an equation Fe2S3 plus H2. Then what do you get? Iron metal. The final mass obtained was 0.824 grams. Then another mass M of mixed X was heated at high temperature in air. Both aluminium sulfide and ferric sulfide decomposed, giving SO2. They have given this time the gas. They have given SO2 here. They have helped you. This SO2 gas was bubbled through a solution of H2O2 and oxidized to H2SO4 acid, which is the only product. So they have given that one also H2O2 plus H2O2 plus SO2, you are getting H2SO4. When in this entire solution was titrated with standard 1M sodium hydroxide solution, in the presence of phenolphthalein indicator, the burette reading was 36 centimeter cube. Write the balanced chemical equation for the reaction of Fe2H3 with hydrogen gas. Right. So first of all, they have asked to write the balanced reaction with the Fe2H3 with hydrogen gas. Yes, Puta. Now, what might be the reaction with Fe2H3 and hydrogen gas? Yeah. You guys. Yes. What might be the reaction between Fe2H3 and the hydrogen gas? They have told already. It goes for Fe here. The one part go for Fe now. Other one will be what? H2S. One will go to Fe now. Other one will be H2S. So one will be in Fe. Other one will go to S. So one is iron. Again, Fe2H3 will go to Fe2H3 will go to Fe and H2S. Then second one, write the valence chemical equation of the reaction of SO2 is H2O2. Give H2SO. They itself have given, so no need to worry about that. SO2 and H2O2 only mapping H2SO4. So automatically it is balanced. Right? So that was not a big problem. So the third one, calculate the mass percentage of aluminium sulfide and ferric sulfide in the mixtures. But what you have to do now, you have to write the balanced reaction for aluminium sulfide with burning in air and ferric sulfide burning in air, because they have given heated at high temperature in air. Air means oxygen. So aluminium sulfide with oxygen, what might they give? They have given the gas also. They have given SO2. Then what is the, apart from SO2, what you might get? Aluminium sulfide plus aluminium, with the aluminium sulfide you get aluminium oxide. With ferric sulfide you will get ferric oxide. Okay, you'll get those two things. So after that, they have told whatever the sodium hydroxide solution, okay, when this entire solution was treated with the standard one name, sodium hydroxide, it means whatever the H2SO4 there, it's treated with sodium hydroxide, you know the valence reaction, sodium sulfate and water. All right. So you get these things. Without using these things, okay, what we can do now, you'll get the valence reactions like this. Okay. So when we get the valence reaction, wait. After that, we have to go with the simultaneous equation and we can solve this problem, right? So we'll solve this problem in our next session. So you guys try this. You guys try this question, right? We'll try solve this in the next class, right? At the moment I have to wind up due to unavoidable circumstances, right? So therefore we'll continue this question in our next class. So you guys try this, okay? So now I just gave some idea that using those things. Now you have to take the mass of aluminium sulfide as X bit. You can take the mass of ferric sulfide as something like Y. Using those, you can build up to simultaneous equations, and you can do this. But try this. We'll discuss in the next class. Okay. Right. So we'll wind up the session now. Then thanks for participating. And tell this. Okay. Then tell this to your friends as well about the session. Right. So this is really important to practice the chemical calculation. But only that we are discussing so many questions for chemistry. Okay. So this is a free session. So ask everyone to join and get the maximum use. Right. So we'll see. Is there another session until then? Goodbye. Thank you.